Assalamualaikum and hi students. This is a lecture video of BMCG 1013 Differential Equations, Chapter 3 Laplace Transform. In this video, we will cover three LOs, which are: first, to determine the Laplace transform of a function, and for the second and third LOs, it is to apply the linearity property and first shifting property to find Laplace transform. 3.1 Properties of the Laplace transform. So this is the definition of Laplace transform. The Laplace transform of a function ft is defined by L. This is the notation for Laplace. Laplace of ft equal to fs, capital Fs, equal to integration exponent negative st multiplied by ft dt. And then the limit is from 0 to infinity. Okay, one example, if I have ft equal to a and a is a constant. Okay, and I want to find what is the Laplace transform for this ft, which is fs. So fs is equal to integration from 0 to infinity exponent minus st multiplied by a. A is a constant again, and then I need to do the integration with respect to t. So for this one, since a is constant, so I can put it outside. So a integration of exponent negative st is equal to exponent negative st divided by negative s. And the limit is from 0 to infinity. Then substitute the limit. I have negative a over s exponent infinity, negative infinity minus exponent 0. And this is equal to negative a over s exponent negative infinity is equal to 0 minus exponent 0 is 1. So this is equal to a over s. So the Laplace transform for a is equal to a over s. And we have a table for Laplace transform. We have 7 functions here, ft. If ft equal to a and a is constant, we have fs in form of a over s. And if we have polynomial, t to the power of n, and n can be any number. Okay, so you need to find what is n factorial divided by s to the power of n plus 1. And then for exponential at, it is 1 over s minus a. Sin at, cos at, hyperbolic sin at, hyperbolic cos at. We have this transformation fs. Just refer to the table. Example 3.1. Find what is fs, what is the Laplace transform for this 7 function ft. Okay, let's start with a. Ft equal to cos 7t. So the a here is equal to 7 cos at. So refer to the table. For cos at, we have s over s square plus a square. So fs for cos 7t is equal to s divided by s square plus a square, which is 7 square. And this is equal to s over s square plus 49. That's it. Okay, and then for b, we have ft equal to t cube. For t cube, use this second row. So you need to find, so for t cube, our n is equal to 3. So fs is equal to 3 factorial divided by s, 3 plus 1. And for 3 factorial, it is 6, using your calculator. Okay, so s to the power of 4. And then for c, ft is equal to exponent minus 5t. A is equal to negative 5. So Fs is equal to 1 over S minus 5. And this is 1 over S plus 5. Okay. T, when Ft is equal to sine half T. Okay, sine AT. So A is half. A is equal to half. So Fs is equal to A, which is half, divided by S square plus half square. So this is equal to 1 over 2 S square plus 1 over 4. Eft is equal to pi. Pi is a constant. So Fs for a constant is equal to pi over S. Ft equal to hyperbolic cos pi t. Okay, A is equal to pi. So Fs is equal to S divided by S square minus pi square. And last but not least, we have G. Ft equal to hyperbolic sine pi t again. A is equal to pi, and our Fs is equal to pi over S square minus pi square. Simple. The first property we have here is the linearity property. Okay, so let f1, f2 be functions whose Laplace transform exists for s greater than a, and c be a constant. Then for s greater than a, we have these two property. If we want to find the Laplace transform for two function, f1 and f2, so it is equal to find what is the Laplace transform for f1 first, and then you have to add or subtract with the second Laplace transform for f2. And then for the second properties, if you want to find the Laplace transform for multiplication of constant with a function, so you can have c, the constant, multiplied by the Laplace transform of f. Okay, so we have three examples in example 3.2. Okay, first we have A equal to Laplace transform of 3 exponent 8t minus 5 sine pi t. Okay, by using the linearity properties, we can write this as Laplace transform of 3 exponent 8t minus with Laplace transform of 5 sine pi t, using the first property. Then, using the second property, this can be written as 3 Laplace transform of exponent 8t minus 5 Laplace transform of sine pi t. So now you can find what is the Fs for this operation. So 3 multiplied by Laplace transform of exponent 8t is equal to 1 over s minus 8 minus with 5 Laplace transform of sine pi t is equal to pi over s square plus pi square. So the last answer is 3 over s minus 8 minus 5 pi over s square plus pi square. Okay. Example B. Okay. Need to find what is Laplace transform of cos square 2t. for this one, you need to know what is the substitution for cos square 2t, because from the table we don't have a function ft is equal to cos square. We just have cos at. So you need to know what is the substitution. Use the trigonometry identity table. So for this one, you need to find Laplace of, okay, since cos square 2t is equal to 1 over 2 cos 4t plus 1. Okay, so we need to find what is Laplace transform of this. 1 over 2 cos 4t plus 1. So this is equal to 1 over 2 Laplace transform cos 4t plus 1. 1 over 2 multiplied by Laplace transform for cos 4t is equal to s over s square plus 4 square plus constant 1. The fs for constant 1 is equal to 1 over s. Okay. So this is equal to 1 over 2 s over s square plus 16 plus 1 over s. Simplify this, you have s square plus 8 over s multiplied by s square plus 16. And last, for C, need to find what is Laplace transform for 3t square plus 5 over 2. Okay, for this one, 3 Laplace transform for t square plus 5 over 2 Laplace transform of 1 or constant. So for t square, we have 2 factorial divided by s2 plus 1 s cube plus 5 over 2 multiplied by 1 over s. And last answer is 6 over s cube plus 5 over 2s. The next properties is first shifting property or first translation property. So the Laplace transform of ft is equal to exponent at multiplied by gt is given by fs equal to, find what is the Laplace transform for exponent at gt, and it is equal to gs minus a. Okay, and gs is Laplace transform for gt. So for first shifting property, we will try to find the Laplace transform of a function if it is a product of exponent at with another function. Okay, so before this, we just have a single function. We have ft, we find what is Laplace transform for ft. But now, what if the function is a product of a function with exponential? Okay. In example 3.3, we will try to solve two functions involving exponential function, okay, using the first shifting property. So first one is we try to find the Laplace transform of exponent pi t multiplied by sine pi t. So what you need to do first is to determine what is your a. Okay, so a basically is from the exponential. So we have exponent at. So a now is equal to pi. And this is the gt. Okay. So this is the another function. This is gt. So gt is equal to sine pi t. And then from gt, find what is the Laplace transform for gt. So the Laplace transform for sine pi t is equal to pi over s square plus pi square. Now you have the gs. Okay, by using first shifting property, your Fs is equal to Gs minus A. So Fs is equal to Gs minus A, and substitute A is equal to pi. Okay. You have Gs, and then you need to find what is Gs minus pi. Means every S in Gs need to be substitute by S minus pi. So Gs minus pi is equal to pi divided by S minus pi square plus pi square. Simplify this, you have pi divided by S square minus 2 pi S plus 2 pi square. I repeat, so Gs, you have pi over S square plus pi square. So to find what is Gs minus pi, you need to substitute this S minus pi into this S. Okay. Let's see the second example. Again, start with finding what is your A. So basically A is equal to 3 and GT. GT is the other function. Okay, the other function, so T squared. And then from GT, find what is your GS. Find what is Laplace transform for T squared. So you know this is 2 factorial divided by S2 plus 1, 3. So GS is 2 over S cubed. And then Fs is equal to Gs minus A. And A now is equal to 3. So we have to find what is Gs minus 3. Again, substitute S minus 3 into this S over here. So the last answer, Fs is equal to 2 divided by S minus 3 cubed. The last property is the derivative of the Laplace transform. Okay, now what if you have to find the Laplace transform for a product of t to the power of n with another function t. Okay, so if you have a product of tn with gt, so this is how you find Laplace transform. So you need to find what is n, determine what is n, and then negative 1 to the power of n, and then you need to find the derivative of gs. Okay, it depends on the number of n. So if you have n equal to 1, so you just need to find what is the g prime. And if n is equal to 2, so you need to find g double prime, and so on. Example 3.4, we have to find Laplace transform for t square sine 2t. So now our gt is a product of t square and sine 2t. Okay, so first start with determine your n. In this case, the n is equal to 2. Since we have t to the power of 2. So n is equal to 2. And gt is equal to sine 2t. Okay. And then from gt, we find what is gs. Gs, Laplace transform for sine 2t is equal to 2 over s square plus 2 square. And 2 square is equal to 4. Okay. Next, refer to your n. So if n is equal to 2, so you need to find g prime s and g double prime s. If n is equal to 3, you need to find g prime s, g double prime s, and g triple prime s. Okay, so gs, from gs, this can be written as 2s square plus 4 to the power of negative 1. So using the product rule, you have negative 2s square plus 4 to the power of negative 2 multiplied by 2s. So this is equal to negative 4s square plus 4 to the power of negative 2. And then from g prime s, find what is g double prime. From here, it is a product rule. This is your u and this is your v. Okay. So you have negative 4s multiplied by, differentiate this, you have negative 2s square plus 4 to the power of negative 3 multiplied by 2s u v prime plus v, your v is s square plus 4 to the power of negative 2 multiplied by u prime. U prime is negative 4. Simplify this. You have 16s square over s square plus 4 cube minus 4 over s square plus 4 square. And this is equal to 3s square minus 4 divided by s square plus 4 to the power of 3. Okay. Fs, the Laplace transform for this function Fs is equal to negative 1 to the power of n and d and g divided by dsn. Okay, so since n is equal to 2, so we have negative 1 square, okay, and then we have g double prime s. Negative 1 square, you know it is equal to 1, so we just have positive sign 1, and then rewrite your g double prime. So you have 3s square minus 4 divided by s square plus 4 cube. And this is the last answer. For the final example in this video, we have to find the Laplace transform of exponent negative t multiplied by t multiplied by sine 3t. For this example, we can use both first shifting property and derivative of the Laplace transform because it involves the multiplication of exponential and t. Okay, so let's start with the first one. The first one, let's say, I want to start with the derivative. Okay, the derivative of Laplace transform. Okay, so for the derivative of Laplace transform, I need to determine my n first. So n in this case is equal to 1. So my gt becomes exponent negative t sine 3t. Okay, so we need to find what is the gs. In order to find gs, because this is a product of exponential and sine 3t, so you need to determine a equal to negative 1. Okay, you need to use, we start with derivative of Laplace transform, but now you need to use the first shifting property. First shifting property. Okay, so a is equal to negative 1 and let's say ht is equal to sine 3t. So hs is equal to 3 over s square plus 9. Okay, I have my hs, so my gs is equal to hs minus 1 is plus 1, and this is equal to 3 divided by s plus 1 square plus 9. I have my gs and my n is equal to 1, so I need to find what is g prime s. Okay, so this is equal to 3 multiplied by s plus 1 square plus 9 to the power of negative 1. Find the G prime S. G prime S for this is negative 3 S plus 1 square plus 9 to the power of negative 2 to S plus 1. Okay. And this is equal to negative 6 S plus 1 over S plus 1 square plus 9 square. So you have G prime S. Using derivative of Laplace transform, the Fs is equal to negative 1 to the power of n. N is equal to 1. And then multiply by G prime. G prime is negative 6 S plus 1 divided by S plus 1 square plus 9 square. Negative 1 to the power of 1 is equal to negative. So negative will be positive. So the last answer is 6S plus 1 over S plus 1 square plus 9 square. Okay, the Laplace transform for this. Using derivative of Laplace transform and then continue with first shifting properties. Let's see what happens if I start with the first shifting property. If I want to start with the first shifting property, so I need to determine my A first. My A now is negative 1. And my GT is equal to T sine 3T. Okay. And then to find the GS, I need to solve for derivative of Laplace transform because it involves T. Okay. Derivative of Laplace transform here. So since I have T, my N is equal to 1 and my HT is equal to sine 3T. Again, I need to find what is my HS. HS is equal to 3 over S square plus 9. Okay. And then I need to find what is my H prime. S. This is equal to 3 S square plus 9 to the power of negative 1. Okay, so N equal to 1, so I need to find H prime S. And this is equal to negative 3 S square plus 9 to the power of negative 2 multiplied by 2S. And this is 6S over S square plus 9 square. Okay, my GS is equal to negative 1 to the power of n, 1, then multiply by negative 6S over S square plus 9 square. So my GS is 6S over S square plus 9 square. And then I need to solve for Fs. Fs using first shifting properties is equal to GS minus A. Since A is equal to negative 1, so I need to find what is GS plus 1. Okay, so S plus 1, you need to substitute this S with S plus 1. This both S with S plus 1. So 6S plus 1 over S plus 1 square plus 9 square. For second example, this is the last answer when we use the derivative of Laplace transform first. And this is the last answer when we use the first shifting property first. Okay, so we can see the last answer is just the same. So in the case when you have a product of exponent t and other function gt, so you need to solve using both properties. Okay, so that's all for this week video. For next week video, we will see the Laplace transform of unit step function. Thank you.